And by the way, this is why I'm kind of screwing around with having two wave gens up. Because, like, for example, we were dealing with, we were dealing with, DC before as we're trying to, set the, see what the family of curves were like, right? And like I said, before I was interrupted by some obnoxious asshole with a loud ass car stereo to where I couldn't concentrate to finish the fucking video last time. It's about to, kind of point out, the ohmic regions, like at this maximum IDSS, are pretty much in here, right? But, you can kind of see them with a family of curves shrink, where the ohmic region is much lower here. And, if you go look at like the characteristic curve, you can't see the ohmic region on this curve. This is the transconductance curve, and so it's not visible, and that's why, a family of curves is still really handy when working with any transistor because you could tell, kind of where the ohmic regions are, and, by, sweeping across it, you can kind of see, where you want to bias it. So if you were to draw a load line from like 5 volts up to, let's say, 3 milliamps, you want to avoid this region because it's the ohmic region, right? So, and here's the more linear region. That's what you'd want to operate in. And if you recall, that's sort of where we want to bias things over here is up in this region, as far as the gate voltage to current. So, so again, you're looking for, like, let's say around 3 milliamps or so. And, that corresponds to right here, is where you'd, you know, want to put your Q point, but the point is that you're actually biasing it, in the ohmic region, which normally you may not want to do. But at any rate, but still, it allows you to see where this thing actually behaves like more like a voltage controlled resistor, as opposed to an amplifier, because it's going to mostly operate like an amplifier over in this region. So, so that suggests, that you might want to aim, because again, if you drew a load line through this thing, and let's say you set it, because its saturation, would be right up here at 5 milliamps, right? So that's where your load line would be. It'd go from like 5 volts to right around 5 milliamps. So again, you'd actually operate it right around here, with this device, because that would be on a load line curve, so around 2 to 3 milliamps. That's fairly linear. So, in fact, if I ever did a transistor curve tracer, I'd make sure you could actually do load line analysis with it because it mostly be on the PC. So, I mean, why not, right? Um, but at any rate, I just wanted to, kind of finish that thought. But I wanted to point out that why I wanted to have another, waveform generator is because if I go back to, let's say, a triangle wave, well, look what happens. You know why? Because since I screwed with that offset, well, that's being applied to all waveforms, that you can generate here. So now instead of this gate voltage being strictly negative, it's actually going 2 or 3 volts into the positive territory. That's why I put that little resistor, that 10K resistor, um, in series with that, that wave generator in case I accidentally did that. So this shows you what kind of curve you get if it's going into the positive bias region. So, so yeah, you get this big, wedge of cheese here. So, so it's why it's good to have more than one of these. Each of them can have their own setting, and that way, if you dick around, with some of the parameters, because again, I was working with DC, so you know, so it's not a problem because I've got my range set between 0 and minus 2.5 volts. But if you notice, that's the offset voltage it's adjusting. So, but that offset voltage you need to set particularly, for a waveform, because again, it's the same in DC, as well as the waveform itself. But you can see how the the thing scales as I adjust that offset voltage, so you can see where, you know, when it's going negative. So, because it's still positive right now at the peak of that triangle. Again, this thing should work differently. Now we're only just starting to get there because I had that set at like 2.5, minus 2.5 volts or something like that. So, let me go ahead and type that in directly. Okay, so now it should be set to 0, and now we're getting our, waveform. But that's why putting that resistor in there was a good idea, because, that would have possibly damaged the JFET, probably not with the analog discovery since it can't do that much current, but, if you didn't have something like that there, yeah, it might have toasted your device. Um, but at any rate, yeah, I just wanted to kind of point that out. So, but and show you what it looked like in the positive region, because as long as you control the current, you can do that, but you're not really getting amplification, because you forward bias the diode typically when you do that. And at this point, it's not doing it all, because I am still sweeping the drain source voltage, right? So it wouldn't be forward biased like all the time, but you saw that it was operating significantly in the forward bias region. So, but basically that means at some point you're forward biasing the diode, so that's causing the device to act funny, basically. So anyway, just thought I would fill in that blank since that asshole stopped his music. So, cheers.